Okay, I just downloaded the compound conditions start folder if you want to follow along. Otherwise, you can maybe practice this at home because I'm recording it. And so if you want to try some of these and get it to work at your pace instead of at my pace, there's the starter. Go home, start the recording, follow along. If I'm getting too fast, it's going to happen. Pause, finish, keep going. I downloaded it onto the desktop and I renamed it Compound Conditions 4. Let's take a look. What this program is going to let me do is demonstrate the different kinds of compound conditions that we just talked about using the examples that I have in my notes. How do we get to multiple choice type questions? Well, the same way. All right, here's my form. Guess my favorite color. So here's a little guessing game, and again, the instructions inside hopefully will help me remember what I'm supposed to be. Kate, will you grab that door on your way through? But here's another one. Can I go on the trip? Did I raise the money? I checked the sitter. I got a sitter. Check. I got my car fixed. If all three check boxes are checked, then I get to go. Here's the or example. If any one of the check boxes is checked, I get to go. So let's try one of these favorite colors here. And most of these have some kind of a button on them, but these do not. So I'm guessing in the code that one of these buttons are wired together. Yep. Here's RDO color check changed. These are all my radio buttons for colors are wired in here. Assume my favorite colors are red, green, and blue. And the output label's name is label results. If they pick any of those radio buttons, then tell them that they picked one of my favorite colors or ask them to try again. Either one, red or blue. So my question here is if RDO blue is checked, or notice how funky that looks. Takes about 15 years of getting used. Maybe Paul's a little brighter than I am. 3 years, get used to it. All right. But that means or. If you didn't put spaces around it, it looks like a couple of L's and it's really hard to read. If the blue button is checked or the red button is checked, then we say in label results dot text equals that's a favorite color. Else, we either wipe the label out or we tell them, nope, that's not, try again. It's still an if statement. Still has an else clause. But now the condition is compound. If either one of those radio buttons is checked, tell me that it's a favorite color. Red, favorite color. Now notice again that all 6 of these radio buttons are wired into this check changed event. I did that behind the scenes. They're all wired into here, so anytime I click on a radio button, this code executes. Pink, nope. Yellow, nope. But it's a compound condition. Instead of asking 2 questions, I really ask one with 2 conditions. Because we could have said, if it's red, else if it's blue, same message, else, nope. That would work. But by using a compound condition, I only have to put the message in there twice, or once, excuse me, not twice. Questions? All right, the AND example has a checkbox on it. In order to vote, you got to be the right age, and you've got to be registered. Okay, so here I've parsed my age, even threw in a try catch to say please enter an age, and now I've got an age, and in order to vote you must be eligible, or you must be the right age, and you must be registered. So again, an if statement. If the age is greater than or equal to 18, and that one's not so bad, just make sure it's doubled, and check registered is true. It's checked. Notice I'm not double equaling true. If that's the case, then label eligible dot text equals you can vote. Else we're going to call security. Try to sneak in. So in this case, the user gets to use text box. Type in an age here, and then we can check. This age is correct, but they're not registered. I am registered. Oh, well then you can vote. I'm 9. Call security. Let's put that little kid in jail. Trying to vote. Oh, I'm sorry. I'm 19. Oh, okay. Then you can vote. But both conditions must be true in order for the end result to be you can vote. Both conditions must be true. If either one of them is wrong, if I'm a 9-year-old who's not registered, you can't vote.
No, now when you're 9.
Now when you're 9, 11 maybe.
If you sweet talk me.
Bring donuts. Okay. Questions? Here's the can I go on the field trip? Put 3 conditions together. If I raise the money, and I find a sitter, and 2 ands, I get my car fixed, then I get to go. That's a great name. Can, go, and. Dot text equals you can go. You just keep chaining them together. And remember, you can split the line just to anywhere you want, but what I normally do, what many people would suggest, is split it here so that you can see the and in front of this. I also occasionally will split after, leave the and up here, so when I'm reading this, I can see I'm not done yet, there's more coming. But here it still fits. If there were 4 of them, I got to raise the money and my friend's going and my iPad's charged and all these other requirements to go. You can just keep tacking them on. Conceptually, looking up on the screen, when do I get to go? What do I have to do to go? Check all the boxes. Any one of them is gone, I'm done. With and conditions, you really don't need to test them all because it's really pretty hard to screw up. Test them all on, test them all off, and maybe just to make yourself happy, test one in between. But you got to fill them all in. The or example. If, check money or, I raise the money for the or condition. If that's checked, or check money, oops, check free. If that's checked, or check parents. I'll just steal these. Just chain them together. Now, when do I stay home? Only when they're all off. Anyone on is good enough. You get to go. Now the fun one. Get to go to the bar. Now in this case, I decided to use radio buttons for clear or snowing. Sometimes radio buttons are a little easier to understand than a checkbox. If I had a checkbox here for snowing, that wouldn't be too bad. But checkboxes for male and female doesn't work very well. Full and part-time, they don't work very well. It can get confusing if you're not careful. Or you tick people off. Put checkbox in there for are you male? Check this if you were male, then the females get mad. Or if you put the females in there, then the men get mad. Radio buttons. So in this case, I'm going to use radio buttons, but it really doesn't change my conditions much. If the homework is done, and the test is studied for, or it's snowing. And the label name is bar, okay. Okay, so here's my example right here. Going to help me decide. You can imagine turning this into a little iPad app that you carry with you wherever you go, in case your mother's not around to tell you whether to go to the bar or not. When am I going? There's really no easy answer, right? Except for when it's snowing. Because we determined that this is an or clause, so if it's snowing, I get to go, regardless of what happens up here. It's called Boolean algebra, Boolean logic. If one part of a condition is true. Now it's clear though. I really don't get to go except according to my test plan when all my work's done. If anything's missing, I gotta stay. So using compound conditions, the point really is using compound conditions, you can create complex logic that a program can respond to help programs make decisions. Is this account overdrawn? Did the user want to be added to our email list? If the checkbox is checked, go out over there. Is the email valid? Oh, that's another question. So that's an and condition. If the checkbox is checked and the email is entered or valid, then add them to our mailing list. It's the kinds of questions your computers are making all the time. Now, I mentioned to you that occasionally, if you make a mistake, particularly with these compound conditions that are different compounds, true and false, or an and. Let me show you that example. I can get my screens arranged here. What happens if I accidentally do this? That's not what I meant to say. You can flip these around pretty much all you want. As long as the snow is next to the or, you could put that first if it's snowing. Or, my work's done, test and homework. You can flip those around because the and condition has precedence. But now I've overridden that precedence and said, do this. Let's run through the test using my truth table and see how many times the answer is wrong. So the first one's supposed to be true, true, snowing. I'm supposed to be able to go. Got the right answer. Good. True, true, not snowing. I'm supposed to stay home. Uh-oh. That one's wrong. So that's one. True, false. Snowing. I can go and I should. Correct answer. True, false, not snowing. I'm supposed to stay home. No, it says stay home. So far, I've done 4 tests, 1 wrong answer. Didn't do my homework, did and it's snowing. I should be able to go. Oh, making me stay home, even though it's snowing. Stupid app. 2 wrong. False, true, false. False, true, false. Supposed to, false, true, false, stay home. Stay home. False, false, true. I should go. Oh, there's the 3rd answer that's wrong. And false, false, false. I should stay home. 3 out of 8. Yes, ma'am. Did you put the parentheses in like I did?
Oh.
I added parentheses to make it wrong, to show you that even when you use these complex conditions. 3, if you don't test them all, there's a possibility you're going to miss the wrong answer. You're going to get the wrong answers. You got to test them all. And an app is important. To this one, you want to make sure you're getting the answers right all the time. But 3 out of 8 gave me bad answers. All right, a couple of trickier ones. Let's move on to them. Take these parentheses out. Again, this I'll post on OneDrive so you can see it. This next one, I have check boxes for guess my favorite color. What I want you to do, I'm going to give you about 5 minutes. Grab a piece of paper and with your next door neighbors, draw a quick little flowchart. If the user selects only those 2 colors, red and blue, that's my favorite colors. If they pick one but not both, let them know. If they pick them both but they have extras, tell them no cheating. Because if I have to pick the 2, I need a little different logic here. About 5 minutes. All right, recording should have been on, but I forgot to turn it on. So first thing, we came up with a nice solution on the board. You came up with a nice solution on the board that looks like this. If they're both checked, then maybe they got them, but if any of the other ones are checked, and notice the ors, if any of the others are checked, then it's not fair. Otherwise, if it's just those 2, because none of these are checked, just those 2, then they got them. If it's not both of them, and was it 1? Yes, got 1, try again. Otherwise, they didn't get anything. Keep trying. The other solution that I came up with was to first, and this is some pseudocode, was to first count them, count the selected items, and then if there's more than 2, tell them it's no fair. Otherwise, if it's red and blue, they must be right because there's no others. If it's red or blue, tell them 1, etc. And here's the translation. The tricky part was create a counter. This is a variable, it's called a counter. Counts up by 1s usually, by 5s, by 10s, but usually by 1s. And every time a checkbox is checked, count it. Sequential ifs. And we tested that and it seemed to work. We tested that first with a breakpoint. And then we wrote this code to solve it that way. Basically translated my pseudocode if the count is greater than 2, and actually we decided if it's not equal to 2, that way if they only pick 1, it's still no fair, because it simplifies the game if they only pick 1. If the count's not equal to 2, let's put it back. If it's greater than 2, then no fair. Otherwise, they got them, they got them. If they got 1, they got 1. Otherwise, no. So 2 different solutions that solve the same problem. Sometimes counting helps. So I'll leave both of those lit up. I think what will actually happen here is it'll solve the puzzle twice and still give you the right answer. It shouldn't make any difference. So I'll leave them both there. All right, what else is on my form yet? We did this one. Short circuit. We haven't talked about it yet, so let's go to the notes and talk about short circuiting. In this condition, no, not that condition. Make it a little bigger so we can see. In this condition, if I can't raise the money, do I have to ask the rest of the questions? Right? No. Because if one condition is false, the rest of them are not processed. Or the rest of them, I don't need to process them. And C# knows this. And it makes your programs more efficient, and sometimes you can use it to your advantage. I'm going to show that to you in a second. C# will do what's called short circuiting. It will quit processing this condition as soon as it finds a false. So if this is false, it never even checks to see if you got a sitter or if your car's fixed, just like your mom wouldn't ask. They just say, nope, you don't have the money, don't bother. Same thing down here. If I raise the money, do I need to care? Do I care? Does it matter if the students go free or if my parents give me money? No, because the answer is the same. I might be more ecstatic, but we're not measuring ecstasy here. So no, you're going. That's all that matters. C#, again, recognizes that situation. And whenever it comes across a compound condition, and it finds a false, it quits analyzing. The author of your text says, here's a tip. When you're doing an and condition, always put the condition least likely to occur. The one that's most likely to be false first. You'll save billionths of a second because it might short circuit if it's likely to be false and it's first, it's going to short circuit the rest more often. Interesting. Never thought about it. Billionths of a second. With or, whenever we hit a true condition, it stops analyzing and it says the answer is true, moves on. Again, the book says put the condition most likely to be true first, because if you're using or, because as soon as we hit the true, we can stop analyzing and save billionths of a second. It's called short circuiting. All languages except Visual Basic short circuit by default. In our JavaScript class this afternoon, we had a circumstance where we didn't want it to short circuit. We wanted it to keep processing. And so we had to do some gymnastics to get it to not do that. Most of the time, this is exactly what you want. You want it to short circuit. Let's see an example of that and where it might come in handy, and then we'll call it a day. Here's my short circuit test score. If the user types something bad in that text score and I can't parse it, should I keep going and check to see if their score is greater than 60? No. If, how was I going to write this? Let's just do it with a blank. If txt score is blank, that's going to crash my program, right? Well, no. An empty string is not going to crash my program. If I try to parse it, it'll crash. If it's not equal to the empty string, and when I parse it, it's greater than 60, probably want to parse it double here. Notice I didn't even make a variable for it. Then they passed. Else they fail. I'm going to leave my score blank. Now it's going to tell me that I failed, but my program didn't crash. Why not? It should have hit that in parse. No. The point here is not that this is a perfect solution to this, but the point is, because this was false, it never processed the parse. It never got there. And occasionally you can use that to your advantage. It's not in this unit. I don't think it's in this class. It's just something I want you to be aware of, that short circuiting happens. Sometimes it comes back to bite you. Sometimes you can take advantage. You're using Visual Basic. You really got to go out of your way. But it short circuits. It never got here. This blank, when we parsed it, should have crashed. It didn't, because it never got there. And that was the point. Okay, let's stop there. When we come back tomorrow, what else we got? I think it's random numbers. Ooh, fun stuff. Yep. Case sensitive compare. We already did that, didn't we? Didn't we do that with red, green, and blue? Or no, the animal talking. Was it a dog or was it a cat? We converted it to lowercase, and that's what this would do. We've already done that. But next time, we get to play with random numbers. How do we generate them? Because your math program needs it. Your new math program, when the user says new problem, you pick 2 random numbers. Your program picks 2 random numbers. Between 1 and 10, 1 and 20, whatever the user picks. How do we do that? I'll show you how. See you then. I'm thinking we're going to look at about an hour of lecture on Wednesday and then done. So you'll have 2 hours of lab to start working on your Unit 5 stuff. At this stage, if I were you, I'd be most of you after tonight, right? We'll have all your Unit 4 programs done, so you'll have nothing to do, except 600 updates. But you'll have nothing serious to do. I would recommend the Unit 5 worksheet.
Monday Night Football.
Or take a couple days off.
That's what I'm talking about. That's what's happening.
Of course, that always comes back to haunt you.